Welcome to section 3.1, reference angles. This section has three objectives. The first learning objective, A, is name the reference angle for a given angle. In this section, we will explore how to find approximate values for trigonometric functions of any angle, not just those between 0 degrees and 90 degrees. To do this, we use the reference angle, also known as the related angle. The reference angle for an angle theta in standard position is the positive acute angle between the terminal side of theta and the x-axis. In this book, we'll denote the reference angle as theta hat. Key components about reference angles. Theta hat is always positive. Theta hat is always between 0 degrees and 90 degrees. And a reference angle is always acute, regardless of the quadrant in which theta is located. So using reference angles allows us to extend our understanding of trigonometric functions beyond the first quadrant and apply them to angles in all four quadrants. In our first example, we're asked to name the reference angle for each of the following angles. So for each of these angles, I'm first going to identify what quadrant they land in and then identify the reference angle. So in our first one, we have a 40-degree angle. So my 40-degree angle is going to land in the first quadrant. Knowing that my reference angle is always positive, it's always between 0 and 90 degrees, and it represents the acute angle formed from the terminal side to the x-axis, my reference angle then would be 40 degrees. All right, next, 215 degrees. 215 degrees will take me all the way into my third quadrant. It's 215 degrees. So my reference angle would be the terminal side to the x-axis. So let me get a different color here so you can see the difference. So this would be my reference angle. So to find this angle amount, I know that when we start our unit circle, it starts at 0, then it goes to 90, then it goes to 180, then 270, and then back to 0 to make a complete 360 degrees. So if I eliminate 180 from the 215, I'll be able to get my reference angle, or the part you could say that is missing to complete my 215. And so my reference angle will come out to be 35 degrees. Okay. All right. Next we have negative 250. So negative 250. Since it's negative, we're going in the opposite direction. So that will land us in quadrant 2. Let me redo that terminal end. Quadrant 2. There we go, much better. Negative 250 degrees. So we're looking for the reference angle, this angle right here. So similarly to the 215, if I subtract 180, because that's my straight line angle, I'll get this missing piece. So if I subtract 180, but in this case, since our value is negative, I'll add 180, and I'll get a 70 degrees. it's negative 70 degrees, but I'm going to use 70 degrees because I know my reference angles are always positive. 160 degrees, so this is between the 90 and 180. Doesn't have to be exact, we just want a representation of what it could potentially look like. So I'm looking for my reference angle here. So to find this difference, I'm going to subtract 180 from 160, and I'll get 20 degrees. Next is 325. 325 is going to take me all the way into the fourth quadrant. 325 degrees, and I'm looking for this reference angle. So it's almost making a complete circle. So if I subtract 325 from 360, then I will get 35 degrees. And then we have 130. So negative 130 is almost at 180. So it's going to end up in the third quadrant. Negative 130 degrees. So since our reference angle always matches to the terminal side to the x-axis, we need to identify what this reference angle would be. If we have this reference angle, we would have a complete 180 degrees. So I'm going to subtract 130 from 180, and I would get 50 degrees. Okay, and so that would be my reference angle. So when working with angles between 0 and 360 degrees, we can determine their reference angles using the following rules. If theta is in quadrant 1, then theta hat, or our reference angle, will equal theta. If theta is in quadrant 2, then our reference angle, or theta hat, would be 180 degrees minus theta. If theta is in quadrant 3, then theta hat will equal theta minus 180. And if theta is in quadrant 4, then our reference angle will be 360 degrees minus theta. These reference angles help us simplify trigonometric calculations by relating any given angle to its corresponding acute angle in quadrant 1. The reference angle theorem states that a trigonometric function of an angle and its reference angle will be the same except for a possible difference in sign. Rather than proving this theorem formally, we'll illustrate it with an example. So consider all angles between 0 degrees and 360 degrees that have a reference angle of 30 degrees. So in quadrant 1, that angle would be 30. So 30 has a reference angle of 30 degrees. In quadrant 2, that would be 150 degrees. 150 degrees would have a reference angle of 30 degrees as well. In quadrant 3, that would be 210. 210 would also have a 30-degree reference angle, and 330, which would also have a reference angle of 30 degrees. If we calculate their sine values, we see that the sine of 30 would be 1/2. The sine of 150 would also be 1/2. The sine of 210 would be negative 1/2, and the sine of 330 would be negative 1/2. So this confirms that any angle with a reference of 30 degrees will have a sine value of either 1/2 or negative 1/2, depending on the quadrant in which the angle lies. So our steps for finding the trigonometric function of any angle, 0 degrees to 360 degrees, we start off with step number 1. We're first going to find the reference angle, and then we're going to use the quadrant-based rules to determine the reference angle. Step 2 will determine the sign of the trigonometric function. So we'll use the quadrant of where our theta is located to decide whether the function is either positive or negative. Remember my nifty acronym, all students take calculus. So in the first quadrant, all trigonometric functions are positive. Second quadrant, only sine and its opposite is positive. In the third quadrant, tangent and its opposite is positive. And in the fourth quadrant, cosine and its opposite are positive. Step 3, we'll rewrite the original function in terms of our reference angle. So we'll express our trigonometric functions using the reference angle. And then we'll find the trigonometric function of the reference angle. So we'll use the known values from the unit circle or our reference angle tables. So by following these steps, we can efficiently evaluate trigonometric functions for any angle between 0 and 360 degrees. Okay, so for exercise 2, we're asked to find the exact value of the sine of 210. So let's first draw a visual of where 210 is located on our unit circle. So 210 would be located in the third quadrant. This is 210 degrees. So our first step is going to be to locate the reference angle. Okay? So we want to locate this reference angle. So since it's in the third quadrant, we are going to subtract 180 degrees from our angle, and we'll get 30 degrees. That's step number 1. Step number 2, we're asked to determine the sign of the trigonometric function. Well, since it terminates in quadrant 3, and according to our acronym, all students take calculus, the sign of theta is going to equal the negative sign of theta hat. Okay. For step number 3, we're now going to rewrite the original function in terms of our reference angle. So the sine of 210 now equals the negative sine of 30 degrees. Okay. And so when we try to evaluate the negative sine of 30 degrees, we will get negative 1/2. So our answer then, the sine of 210 equals negative 1/2. And that is the exact value of the sine of 210. Okay. And so these are the 4 steps that we're going to take in the next problem as well. All right, we want to find the exact value of tan of 225. So let's identify what our angle looks like and what quadrant it stops in. 225 will land us again in the third quadrant. This is 225 degrees. We want to identify our reference angle. So for step number 1, we'll take 225 and subtract 180, and we will get 45 degrees. Step number 2, we are going to identify the sine of our reference angle. So we know that we are in quadrant 3, and we know that in quadrant 3, only tangent is positive. So that means the tan of theta is going to equal a positive tan of theta hat. So we're going to now evaluate our reference angle. So the tan of 225 is going to equal the tan of 45, which equals 1. So the tangent of 225 degrees equals 1. Awesome. And you can evaluate these tangents either using the unit circle, our angle table values, or your calculator. All right. Exercise 4, find the exact value of the secant of 300 degrees. Well, 300 degrees is going to land us in the fourth quadrant because it's past 270. This is 300 degrees. So for step number 1, we want to find our reference angle. So we are going to subtract our angle. Oops, number 1 first. We're going to subtract our angle from 360 degrees. And we see here that our reference angle is 60. For step number 2, we have our terminal side in quadrant 4. According to our sign, only cosine is positive in quadrant 4 and its opposite. Okay. Since we're dealing with secant, we can evaluate this using cosine to help us. So we know the cosine of theta is going to equal the cosine of theta hat. So that's the reference angle. So evaluating this, secant of 300 degrees is going to equal secant of 60 degrees, because remember cosine and its opposite, which is secant, are both positive. Now secant of 60 degrees in terms of cosine would be 1 over cosine of 60 degrees. Okay. When we evaluate this, we're going to get the value 2. Okay. So the secant of 300 degrees equals 2. All right. Okay, our next objective. Find the coterminal angle of a given angle. Two angles are called coterminal angles if they share the same terminal side when drawn in standard position. Coterminal angles always differ by multiples of 360 degrees, since one full rotation around the unit circle brings the terminal side back to the same position. For example, 10 degrees and 370 degrees are coterminal because 370 equals 10 degrees plus 360 degrees. Another example, negative 45 degrees and 315 degrees are coterminal because 315 degrees equals negative 45 degrees plus 360. So a key property of coterminal angles is that their trigonometric function values are always equal. This means that for any integer k, sine of theta plus 360 degrees times k equals the sine of theta. And cosine of theta plus 360 degrees k equals cosine theta. This property allows us to simplify calculations for angles that are larger than 360 degrees or smaller than 0 degrees by finding a coterminal angle between 0 degrees and 360 degrees. Once we determine the coterminal angle, we can use the standard steps to evaluate its trigonometric functions. Okay. So let's find the exact value of the sine of 405 degrees. So 405 degrees, all right, 405 degrees is going to be more than 360, okay? But how much more? Well, in step number 1, we can subtract 360 from 405 to find its coterminal angle, which would be 45 degrees. That means 405 degrees is going to land in quadrant 1. That also means its reference angle is going to be 45 degrees. Okay? So we can evaluate this using the reference angle 45 degrees. So for step 2, we know it terminates in quadrant 1. In quadrant 1, all trigonometric functions are positive. So that means the sine of theta is going to equal the sine of theta hat. So the sine of 405 degrees equals the sine of 45 degrees. And the sine of 45 degrees is the square root of 2 over 2. Thus, the sine of 405 degrees equals the square root 2 over 2. Okay, awesome. Okay, our third objective, approximate angles using trigonometric functions. So for angles that do not correspond to exact values from the unit circle, we use a calculator to find approximate values for sine, cosine, and tangent. So to calculate sine, cosine, or tangent using your calculator, you're going to follow these steps. The first thing that you want to do is you want to ensure your calculator is in the correct mode. So most calculators default to radians, but since we're working with degrees, we can switch your calculator to the degree mode if necessary. So you'll want to check or change the mode to make sure that it aligns with the problem that you're doing. Okay, so if you're using the TI, you would press mode and then select degree or radian if your problem was working in radians. Then enter the angle and apply the function. So then you'll press the appropriate function key, whether that's sine, cosine, or tangent. You'll type in the angle value and then you'll press enter to get your result. I encourage you to pause and check your calculations by verifying that you obtain the correct values for these examples. So pause the video, work through these 9 problems, and make sure the values that you get in your calculator match the ones here. By practicing these steps, you'll become comfortable using your calculator to evaluate trigonometric functions for any angle, including those that don't have exact values from the unit circle. So in our exercise here, it says find theta to the nearest degree if cosine theta equals negative 0.8910 and theta terminates in quadrant 2, with theta being between 0 and 360 degrees. So we know that cosine of theta equals negative 0.8910. Okay? So to find theta, okay, we are going to use our reference angle to identify what theta could potentially be. Okay, so we are going to take the inverse of cosine, and since we don't know exactly what theta is, we're going to use a reference angle to identify this angle. And I put an equal sign here. We're going to take the inverse cosine of negative 0.8910, and we'll enter it into our calculator, and we should get approximately 27 degrees. Okay? So we know that our angle of theta terminates in quadrant 2. It terminates in quadrant 2. But we have some angle that terminates in quadrant 2. According to our reference angle, we know that our reference angle is 27 degrees. So if we wanted to find out what theta could potentially be, because theta could be multiple angles, but we want to make sure that theta is between 0 and 360. So we will take 180 and subtract 27, and we'll get 153 degrees. So that means theta equals 153 degrees. Okay? All right, let's do another one. So we're going to find theta to the nearest tenth of a degree if the tan of theta equals negative 1.2437 and theta terminates in quadrant 4, with theta being between 0 and 360 degrees. So we know the tangent of theta is negative 1.2437. We don't know what theta is, but we'll use its reference angle to help identify the angle. So we'll take the inverse of tan of negative 1.2437, and we will get approximately to the nearest tenth 51.2 degrees. Okay? So that means, if we were to draw our image, we have an angle that terminates in quadrant 4. It's between 360 degrees. Our reference angle is 51.2 degrees. So to find theta, we're going to take 360 degrees minus 51.2 and get 308.8 degrees. Okay, so that's theta that has a reference angle of 51.2. Okay. Next, we're asked to find theta if the sine of theta equals negative square root 3 over 2 and theta terminates in quadrant 3, with theta being between 0 and 360 degrees. Okay. Well, the sine of theta equals negative square root 3 over 2 is one of the values from our table of exact values. Okay, so this is one of those special triangles. Okay, and we would know that the sine of 60 degrees equals the square root 3 over 2. It's from our 30, 60, 90 triangle. Okay, So that means our reference angle is 60 degrees. Okay? Since theta in our problem terminates in quadrant 3, and we know that the reference angle is 60 degrees, we can find our angle theta. So theta will equal 180 plus 60 degrees, which equals 240 degrees. 240 degrees. Awesome. Great. Now we're asked to find theta to the nearest degree if the secant theta equals 1.3054 and theta terminates in quadrant 4, with theta being between 360 degrees. So they told us that the secant of theta equals 1.3054. Okay? Secant is the opposite of cosine. So we can rewrite this as the cosine of theta equals 1 over 1.3054. Okay? So if we found the reference angle, theta hat, we would take the inverse of cosine of 1 over 1.3054, and we would roughly get to the nearest degree, when you enter in your calculator, 40 degrees. So we know our angle terminates in quadrant 4. So we're trying to find. And our reference angle is 40 degrees. So if we were to find theta, we would take 360 minus 40, which would get us 320 degrees. And 320 degrees terminates in quadrant 4. And since we are dealing with a trigonometric function that's opposite cosine, we can check this by substituting in theta for 320, or 320 for theta, which would be 1 over the cosine of 320. And you should roughly get 1.3054 in your calculator. Okay, awesome. Okay, find theta to the nearest degree if the cotangent theta equals 1.8040 and theta terminates in quadrant 3, with theta being between 0 and 360 degrees. So the cotangent of theta equals 1.8040, which means the tangent, its opposite of theta, would be 1 over 1.8040. So to find the reference angle, we will take the inverse tan of 1 over 1.8040, enter that in our calculator, and we would get to the nearest degree, so that's the nearest whole number, 29 degrees. So we know our angle terminates in quadrant 3. And our reference angle is 29 degrees. So if we wanted to find theta, we would take 180 plus 29 degrees, which would get us 209 degrees. To check this, We can substitute it for theta. So the cotangent of 209 degrees is going to equal 1 over the tan of 209 degrees. And you would roughly get 1.8040. Awesome. Great job.